Okay, let's get started. So today I want to try to reinforce the things I've been talking about the last lecture or two about data sources by looking at some examples of data sources and seeing how, real examples of how data is provided and how we would use that data. The final project has been released and is due at the end of the quarter, but the first part is due pretty soon on May 22nd. So you should be thinking now about, you should be doing that part one, which is like figuring out what you want to use for your data source. I also posted homework 5, which uses MySQL, and that'll be due next Friday as well. That's not due for a while, but don't wait until the very last minute to do that homework assignment because it requires that you have login credentials to one of our servers, and if that login doesn't work for you, you'll have to talk to IT to get it fixed. So it might take a couple of days to get that fixed. So try at least to log in. So look at the instructions for homework 5. Try to log in. If you can log in and see the databases, then you can wait for the last minute to do it. But don't wait to do everything for the last minute. Okay. All right. So last time I talked about different data file formats. And data file is just an array of bytes, a bunch of zeros and ones, and how that is flexible enough to let you store data in a lot of different ways. And we looked at how text is represented by an ASCII as using a certain encoding for different bit sequences referring to different characters. How you can use a variable length encoding like UTF-8 to store lots more characters than just the basic ASCII characters. And then using those text formats, we can build data formats like CSV, XML, and JSON to represent data as text, but using a specific syntax for that where that text has specific meaning. Certain symbols have specific meaning. In CSV, commas are important. They separate columns. New line characters mean you're starting a new row, that kind of thing. And XML and JSON are quite different than CSV files because whereas CSV files are basically just spreadsheets, they represent one table, XML and JSON files have structure. They represent a tree of data, and they so you can represent a complex nested relationships with those types of files. But it can present some challenges when you're interpreting the data because it's more complex. You have to understand what format to expect when you're reading it and deal with it accordingly. If you're going to eventually do an analysis with a SQL database, you have to figure out how to translate from those different, tree-like hierarchical formats into a set of tables, which is not trivial at all. So you probably would use a programming language like R or Python to deal with those JSON and XML files if you have those. Okay. Any questions about that? I also talked last lecture about data APIs very quickly, and so we're going to review both of these things today. Data APIs are ways for you to make a network request to a server somewhere out there on the internet to get data from it. And the reason you do this is if you can't get bulk access to the data. In other words, you can't just download all the data because either it's too big or it's dynamic, so it's changing all the time. So downloading it all at once would be silly because you'd have to download a whole new copy every day, and that would be slow. Or maybe the owner of the data doesn't want to give you all the data; they just want to give you little pieces at a time, and they want to check to see how much you're asking for, and then maybe impose some limits on how much data you can get. Anyway, so if that's the case, if you're using a network API to get data, then you basically have to figure out from the data provider what those requests should look like. In other words, what HTTP URLs to request, and how to make different types of requests by changing the URL to specify different parts of the data, and also how to interpret the response that comes back, which probably is a JSON object of some kind. And we'll review that today by looking at some concrete examples of data APIs. Okay. And I hope that you use data APIs in your project, although it's not a requirement. Okay, so let's get into some examples. These are actually a bunch of different projects I found and they're linked to from your project description. So the city of Chicago happens to be like among all the cities I know of. I think they have the best data portal. Like basically anything about the city of Chicago's operations, the government, the parks, the police, all of that information is publicly available online through these data portals, and it's pretty up to date. So, for example, the Chicago Parks District has information about. Let me make it. Has information about events. Okay, so I found this from the Chicago data portal, just a random page I decided to look at. Event permits. So if you want to use if you want to reserve a part of a park for a party or an event or something, you need a permit from the city, and they collect all that data and publish it. And this is basically, so this webpage gives information about it. So it's a table with 78,000 columns and 78,000 rows and 9 columns. And it tells you what the columns are and what the type is. So some of this T means text. Some columns are numbers, some are dates and times. So you basically know who is requesting what park facility and when they're doing it. All right, so here's some sample data. Okay, so this is just a series of events. They're events because the word event is is in the title, but also you see there's a time associated with them. And it's a pretty simple schema. For this data is relatively simple. It's just a list of a lot of one type of thing. So it's reasonable to represent it in a single table. And so that's what they do, right? This is a table with lots of rows. It gives you a preview of the first few so you can see what it is before you download it. And to download it, you can just click a button here, get it as a CSV file. And it's a few megabytes, so it's downloaded. And then when I open it, it'll open up in Excel, like so. Or you can open it in DB Browser for SQLite, load it into a table. Or you can just look at the raw data itself if you open it in like a text editor. So here's what the data looks like at like sort of a low level. Make it a little bigger. So this is the CSV file, so comma separated values. It's just text where every line represents a row. The first one is the headers, and then the first real data row is down here. So it has like a person's name and the date, what location they're reserving and stuff like that, right? So this is a very simple data format, and you can deal with this in, like I said, Excel, DB Browser for SQLite. You can also load it into like your Python or R code very easily into one of the data structures that those languages have available. Okay. It just so happens they provide a data API. Because this City of Chicago data portal, it has this link here for API access. And even if it's a very simple data file, like that can be represented by a spreadsheet that's downloadable, they do provide a URL to fetch the same data programmatically and to return it in JSON format. So you can see the URL is data.cityofchicago.org/resource/ this weird string. This is like the identifier of the data set. But this is like all data at once. So I wouldn't really even call this a data API because you can't get pieces of the data, or it's not clear anyway how you would get pieces of the data. It just gives you all the data in one file, but it's at a web. It's at a certain URL. A real data API would have different URLs you can use to get different parts of the data. Okay, any questions about that? So that's the City of Chicago Park District events. So yeah, looking at the same website, there also is data for Cook County hospitals. I didn't know what this was, so I just clicked on it, and what I see is that there's a zip file I can download, which has some files in it, and these are shape files that require special GIS software. GIS means Geographic Information Systems. So this is a data set of geographic information, actually. And inside that zip file, there are these files, like hospital dot whatever, including shape files, SHP, and there's some XML and whatever. But this is a file format. These files together work with a specific program, ArcGIS, for dealing with geographic data, which personally I haven't used. Maybe I might play with it to see whether it's worth introducing in this class. But I know that this type of file format is useful for like representing property data, like geographic data, like the shapes of different things on maps and different locations on maps, different paths on maps, things like that. So for these hospitals, I think it's showing the location of all the hospitals. They're also, so similar to this, there's another database, which is the boundaries of Chicago neighborhoods, on the same Chicago data portal. This was developed by the Office of Tourism, but the same type of files are provided, these ArcGIS files. And in this case, if you wanted to see, like if you wanted to get in numeric format, in a computer readable format, what the boundaries are of all the different neighborhoods in Chicago, this file would provide it. And then you could do a visualization using that. Or if you had a different data set, like if you had a data set that showed what the coordinates of all the different crimes in Chicago was, you wanted to label those with what neighborhood they were in, you could kind of like combine those two data sets, right? You take the coordinates from those crime events and you somehow figure out which of the neighborhood boundaries it's within. Now you can't really do that in SQL. Now we're talking about you have to pull together a lot of different tools to do that, but the data is available from these different sources to do that. All right, so speaking of Chicago crimes, here is, this is they have a lot of data on from the police department, and they even have a dashboard for you to like be able to browse this data on the web, 2001 to present. And for example, they have different categories. They show like the distribution of different categories of offenses. They show the number of reported crimes over time. You see there's kind of like a yearly cycle. So this kind of like up and down cycle is summer and winter. And yeah, you can build these kinds of visualizations off of a SQL database using a tool like Tableau or other tools and other that are more built from scratch. But in addition to these visualizations, like they also have some geographic visualizations, they also have the raw data available, which is maybe of more interest for you all. So you can, in this case, it's available as CSV files. And it's also available through an API. And actually, it's one big table. So it's a table with 6.9 million rows and 22 columns. It's a bigger table, but it's still just one big table that has one row for each crime and has each report of a crime, and it has different information in the various columns about that crime. Okay. And so again, there's a URL for getting all the stuff in JSON format, and it just returns this really huge JSON file, which it's hard to read, of course, but for a computer program, it's much easier to parse this than that web page. So if you wanted to do an analysis in your favorite programming language, you could have your code download this file and then look for and parse through these different fields for each incident, or you could download the CSV file and deal with that. Actually, dealing with the CSV file would probably be easier. But another thing you can do is, so that URL, even though they provide one URL, it actually turns out that you can modify it a little bit to narrow things down. So this data API provides one URL to get all the data, and then it allows you to add some filters to the URL to narrow down the results. So if I added primary type equals theft, the reason there's a plus here is because you can't have spaces in URLs. So whenever there would be a space, you replace it with a plus, and that's just that name primary type is just something I read off of the CSV file. See right here, this says primary type. Anyway, so if I just add that to the URL and then get that, I get a shorter list, and all of these are just the theft types of crime events, not all of them. Okay, but the details of like how I knew to add this little extra piece to the URL to filter it is because I read the documentation that the Chicago website provided that described like how to get data from them. Okay, so it's up to them to decide what the URLs are available, what variations can be provided, and what's returned in response. All right. So these are just a bunch of CSV files. We saw a couple of geographic databases too. This one's a little bit different and maybe more interesting. You guys have a question? All right. The Stanford Dogs data set. So this is a computer vision data set compiled. So there are like 20,000 images of dogs. So there's a bunch of images categorized by the breed, and these are all pictures of the same breed of dog, okay? And some of them are puppies, some of them are full grown. You can click different ones, and you see the different image. This is a different breed. I don't really know anything about dogs, but they look different to me. Okay? So the purpose of this data set is to allow computer vision researchers to test their code, their algorithms for doing image analysis, right? So like they want to be able to determine, it's actually difficult when given a picture of a dog to determine which breed it is. Like as a person, I wouldn't be able to do it because I don't know dog breeds well. So you can imagine for a computer to just see this, or really anyone to just see this close-up of the face of the dog and then determine which of the 120 different breeds it is would be quite challenging, right? So this is a useful data set because it enables research. So different researchers can try out different algorithms for doing the classification and see how they compare and write papers reporting their results. And in order for that research to work, it's really helpful when you do an experiment like this to release your data so someone else can try a different variation. They can try to do better than you. And if they do that, then they cite you, and you get you get academic points for having citations. But anyway, so this data set is provided by this particular group at Stanford, and you can download it. And there are different pieces of the download. So there's actually this huge file here that has all the images, which is 750 megabytes. So it's just basically like a zip file with a bunch of images. And there also are annotations, which correspond to the images. So like in this class, this isn't an image processing class, and you're not actually, you don't have the tools to do that kind of work. But what's interesting about this is that all those images have annotations, annotation files that look like this on the right. Here's one that this basically describes a file and the qualities of that file. And like there's some information about the file name and the source, but also like what the actual type of dog it is that's being represented, and the coordinates where the dog appears in the image are also included. So this is like information related to that image file that's useful for the analysis that you want to do with it, right? So you could download this data set and process the images, and also load in the accompanying XML files to help your analysis. Okay, and you see, like any other XML file, it's a hierarchical format where you have, like, at the top you have one tag annotation, and then inside of annotation you have some other things, and inside some of those things you have other things. Like size is composed of a width, a height, and a depth, and object is composed of these three things, these various things. Yeah. Any questions about that? Where I put my pointer? All right. So that's a little example of XML, while also giving an excuse to look at dogs. So another data set I found on Kaggle is for University of Washington, Madison. Because they're a public university, they have to make their like data public, their information about themselves public. So they actually released all of the grades from all their courses. I mean, the names of students weren't on this, but you can at least see they did provide all the courses that were offered over the past more than 10 years and grades. And basically the way they provided it was a bunch of CSV files. Each one of those represents a table. And they also provided a SQLite file, which kind of like combines all those as a database. So in a similar manner to what you've been working on in these classes. Yeah. So it's bigger than the ones we've been working on. I think it's about 160 megabytes, and it has a lot of tables. But the complexity is similar to the school scheduling database we've been working with, except it has a lot more data. Like, for example, there are 81,000 different course offerings in this database, and yeah. Actually, I don't think it has individual grades, but it has grade distributions for each class. Yeah, so it doesn't have individual student information, but it has information for all the courses. And because it was this one just happened to be distributed as several different tables because it's a more complex data domain, and it also it wouldn't really fit in one CSV file. All right, so another one that's kind of similar is this baseball statistics database, and in this case, it goes back to like 1871. I'm not sure what all the statistics are that are included, but they're like 27 or so different tables, and they're provided as CSV files. I think I downloaded it somewhere. Yeah, so there's a bunch of CSV files, and you can see, just as an example, they have these like player IDs and years, and this is information about Hall of Fame inductees, and there also is information about individual games and stuff. But this particular data provider decided to, because there are 27 different tables, that's kind of like cumbersome for users to deal with. So they tried to also provide like a single file for those, but they actually chose Microsoft Access and Microsoft SQL Server file formats, which is fine if you use those programs, but otherwise, it's not compatible with a wide number of programs. So for most users, those 27 CSV files are what you'd be using to analyze the data. Right. All right. So another actually really cool and huge data set that I ran into before this class is the Google Engrams data set. And Hey guys, can you stop talking? It's really bugging me. I can hear you. Yeah. So what they did, this was a huge project, and basically they tried to scan every printed book that they could get their hands on, which is very useful for Google's goal of like being a database of all the knowledge in the world, right? And it also is useful for building systems that know how to that can understand human language, right? Because the more examples of human language you have, the better you can you can learn what it means and how language is generally constructed. So one part of natural language processing is, or one useful type of data set are these things called engrams, which are sequences of words that occur together. So let's see. This link here shows an example. So an example of a 2-gram or two words that appear together. So like Albert Einstein is a 2-gram. You often would find those words together because it's a person's first name and last name. And then over time, or in a different, this tool here shows over time how frequently those engrams appeared, and so you can kind of play with this. But it also applies to longer things, like if you type "I like cats," then that's a 3-gram, which has frequency of like 0.000000035% among all the 3 grams, because there are a lot of different possibilities. But it's there are actually a significant number of these examples that Google has in this database, and it tells you like how frequent they are. And if you have a database of all these engrams of like various lengths, I think this particular data set has like the 1 grams, 2 grams, 3 grams, 4 grams, and 5 grams. The longer you get, the more you can kind of like you can actually write text that looks like real like human generated language. You can make a computer that just kind of like babbles by using like, if you start off with a certain word, there's certain words that are likely to come afterwards. If you have like 2 words, you're pretty likely, you know what third word's probably going to come after it. And like the longer your engrams are, the more you can make your random word generation seem like similar to real text that you've seen before, if you're using a statistical method that's based on a real database. Yeah. So so it's a huge data set because it involves text from like a ton of different sources, lots of scanned books, lots of web pages. And so all these little links you see are different files you can download. And so it's split into a ton of different files because it's so huge. And overall, it's I think 2.2 terabytes of text data. So it's small enough that you can download it to a computer, like one computer, but you'd want to do it in chunks, not all at once. Yeah, and it so happens to be it's tab-separated text data. So there are a bunch of files that show like so here's a 5-gram. Sorry. Analysis is often described as, so that 5-gram in a certain year appeared once. So the columns mean on one page in one volume, so in one book. Because this is a pretty specific thing, and it's 5 characters long, or 5 words long. Okay. Yeah. All right. So sticking with Google, I found a few different examples. They're pretty interesting that show that are examples of using a data API, not just downloading files. So the knowledge graph is it's an API you can use to get knowledge from Google. So it's similar to Google search, but it's more computer readable. So you give it a search term, and it returns entities that are like JSON objects. So it's similar to Google search, except it doesn't return pages. It's just like the things that appear on the top of Google search. They're like people or events or places or concepts. those blocks of things, those are the kinds of things that are returned by the knowledge graph search. So an example is the example they gave, which I reused here, is just so Taylor Swift as a query. If you just make this web request here, that this goes to a specific Google server, and then it looks for searches entities with this query Taylor plus Swift, and then at the end there's a key, which is like my password essentially, because this is not an open API. You actually have to pay to use this. There's a free version which I'm using, but you can only do a certain number of these before you have to start paying for it. Anyway, so if I make that request, then what I get back is a big JSON object that has the results. And there's some information at the top just that says what's to come, kind of what the format is of what's to come. But then there's a bunch of items. The first one is a person thing called Taylor Swift. Description's American singer. And there's some article description here describing her. There's a link to a Wikipedia article. So this is very similar to what you'd see in the Google search results, in that like in one of those boxes on top, there's an image, and there's a results score, which is like gives you some confidence about how closely it's related. After that, there also is a music album, which because apparently music albums are things that are available in this database. And there's another music album, and there's another music album, and so on. These are all, I don't know, there's an award ceremony here that's like the fifth result, 2009 MTV Video Music Awards. And because that's related to the Taylor Swift search. Anyway, so I could change this and get different results. Like if I change this query to be, Northwestern, and ran it, I would also get a JSON object back, but it would have items that were related to that particular query. So this is a thing, an educational organization, a movie theater. I don't know how they got that. An organization, a corporation, a college or university, a private university in Evanston, Illinois is the description, and some more details and whatnot. The second thing that comes back is a sports team, Northwestern Wildcats football. And the third thing is Northwestern College, which is a college or university in Orange City, Iowa. And then there's men's basketball team, and then there's the region, Northwestern United States, is another result. So these are all just things that came back from the search result Northwestern, from the query Northwestern. I suspect that if I was not located in this part of the country, I would get different results, because an implicit input to this query is like my IP address, and also my user. This key also, it sort of identifies who I am, so Google can use that information as well to tweak the results. All right, so this is an example of a data API for sure. It's not really a database. It kind of is. I mean, there certainly are databases that are behind this that are providing the information, but it's not like I'm just asking for rows based on columns being equal to something. I'm providing a query that is pretty open-ended, and somehow, in this case, Google is giving me results that are JSON objects that I can interpret in my program and do whatever I want with. Okay. Any questions about that data API, like how it works, how we would use this? All right. So a similar API is the Google Geocoding API. So geocoding is the process of figuring out where something is, and particularly if you give an address like 2145 Sheridan Road, 60208, this API will give you the latitude and longitude coordinates. So it works in a similar way. The URL is different because it's a different API, and then it asks for an address, which I've put in the URL here, and I put in the same key, which is like my Google account password essentially for APIs. And if you click this, then it will give a result. Looks like this. So again, it's a JSON object which lists some results, and there's a certain format they're using to present the results. Like the address is specified in terms of different components, like the street number, the street, the city, some other things. So Evanston Township, Cook County, Illinois, United States, 60208. So it actually, even though I only told it, the request only had 2145 Sheridan Road, 60208, it wasn't totally specific. It figured out that I meant Evanston and Cook County and Illinois in the United States, and it's including that in the result. And then finally, the part that I really want is the geometry here. So it's telling me the latitude and longitude of that location. It thinks it's a rooftop for some reason. I guess because there's a building there, and so that latitude and longitude corresponds to a rooftop. Yeah, it actually gives 2 different corners of the location and other stuff. Okay, that makes sense. So again, if you have a database if you have a data set and you want to sort of enrich it to make better use of it, like if you have that crimes data set that I was telling you about, and it had addresses for the crimes, you wanted to put those on a map, but the data set itself didn't provide those locations, you might want to go through those individually in code, loop through them one by one, and build a query like this to ask another data set. In this case, you're asking Google, what is the latitude and longitude of that location? And you get that back, and then parse this response to get the latitude and longitude down here, and save that somewhere, and that'll help your analysis later on, right? So you can augment or enrich a data source using a data API, or you can get new data from the data API. Right. One of the interesting things about this, again, it's not a database. There's no database that stores these answers directly. Instead, the request is processed by Google in a complex way to figure out which data to send back to me. So for example, I can replace the zip code with the city and get the same result. Right? It can deal with that variation. I can also, instead of giving an address in a city or a zip code, I can just say Mud Library, Northwestern University. I spelled it wrong, not intentionally, but it turns out that even if I spelled it wrong, and even if I don't provide any street information, just like a description of a location, in the same API, so you see up here in the URL, I just have that Mud Library, Northwestern University. That type of query will still give, it'll give a tech drive address and Evanston, Illinois, and it'll give the geolocation, right? So even a very vague location, because of the sort of intelligence of this backend service, can give me some latitude and longitude information that's quite useful. Yeah, question? That depends on, you have to read the specification for the API to figure it out. In this case, it returned 1, but you see that, in this case, results refers to a list. So in JSON, the square brace is a list. So there could actually be more. There could be more than one of these objects here that are results. So it's possible in this JSON for there to be more than one result. I'm not sure if you read the API whether if it gives you more information about whether to expect more than one result. And there also may be a way to modify this query to tell it how many results you want to see in the response. Like you might be able to say limit to like that, or limit 3, in which case the number of results will be limited to 3, or something like that. But a lot of these details come down to reading the documentation for the API. So in this case, I have a link at the top to the documentation, and okay, so it gives some examples, and it shows some example responses, so you can read through this to see what to expect. And then there are more details. There are many pages of documentation here, and these side pages have details about the different variations of the requests that you can make, things like that. All right, so because I already have I made a Google API key I can use that on many different services. So I kind of went wild here, with different Google APIs to give you examples. So one of them is another one of them is Google Translate. So this is definitely not a database API, but it's a pretty powerful backend service that translates from one language to another. So, but it still uses a data API that allows you to provide inputs and get responses. So this URL here for translation.googleapis.com, the format, you'd have to read about the format in the documentation, but here's a simple example. I say the target language is ES, which stands for Espanol, Spanish. I provide my API key, and I also provide the query. Q means query. My name is Steve. When I run that, I get back a response. That's a translation. Mi nombre es Steve. And so that's a translation from English to Spanish of that text, which Google did for me based through this data API, right? And I could put a different target in here. I'm not sure what the 2-letter code is for different languages, but let's try. No, that's not right. CH. I don't know. I'm kind of guessing here. CA. I don't know what language that is. MDic Steve. Maybe Catalonian. I have no idea. Anyway, but the documentation here would say somewhere in here what the different languages were. Oh yeah, so use a 2-letter ISO 639.1 identifier. So let's look up what that is. These are language codes that are standardized. And so I was looking for Chinese, for a like Mandarin. Well, that's. You think CH is the one? ZH. Okay, good. Yeah. I don't know. Is that right? All right, thanks. So I guess that also, interestingly, this response is not ASCII encoded. It must be UTF-8 encoded because you can see the characters it's giving are, are international characters. They're not Latin or American characters. So that's pretty cool, and you can do this yourself by going to one of these web pages, and there's steps to give you the instructions for signing up and getting. The main thing is you have to get an API key. You can actually reuse my API key for a while, but eventually it'll run out of free. You shouldn't do that if you plan to use this. There's a different version of this API. Just as a side note, which is a little more complicated because you notice one of the limitations of this API is that the text you're translating is put in the URL. So my name is Steve. But URLs, like web URLs, are limited in size. They can't be more than 2,000 characters or something. I mean, it's not clearly specified, but there's a limit of a few thousand characters. So if you want to provide a bigger text to translate, you have to actually use an HTTP post request and put the text in a JSON object that you provide. So it's kind of similar to how we got the response in one of these JSON objects. We would construct a JSON object with text that we want to translate, and we would send that in what's called the body of a request. So we'd use a URL. It wouldn't be in the URL, but it would be in the second part. In order to do that, unfortunately, I can't just use a browser because browsers don't provide data. When I just type into the URL, you'd have to do that in a program or on the command line with a curl command or something like that. But the same idea holds. It's still an API where you provide data. In this case, the data we're providing is just the text of the URL, but you can also provide data in other ways, and you get a response. Okay. Okay. So we've seen today that data is provided in many different formats. CSV files are common. There are also these weird geographic data formats like shape files. You might have a zip file with lots of different types of files, like the Stanford Dogs had images and also XML files about those images. You could have multiple tables as different CSV files, or they might be collapsed together, or built into a SQLite database file. I think that's a good way to distribute databases, and that's for the project. That's actually what you're doing. You're combining it. You're making a SQLite database file, which someone else can download and then quickly do an analysis. Anyway, but apart from just files, you also can use REST APIs to fetch data, and you provide information. You provide the query in the URL, by changing the aspects of the URL, and then also potentially by posting a JSON object. And the return value, in other words, the text the server gives back to you is usually a JSON object, and you can interpret that to see the data that you got back, the response to the data. But it's not like SQL where there's a standard format for what the queries look like and what the responses and the responses are always tables. With the data API, the data provider has to give you some kind of a specification for the API, like what are the different URLs you can use, like what parts of the URL do you change to vary your request, and also how should you interpret the responses? What do those responses look like? Like, for example, all those things we were looking at, those huge JSON objects we got back have a particular format, especially for those Google APIs. It's quite complex, and being able to interpret that in a program requires that you know what to see where, or you could just do it by trial and error. You can look at the responses and kind of guess what the different parts are. In practice, I think that's what a lot of people do. But you have to have a starting point at least to know what queries you can make to get data. And actually, that's all I prepared for today. So I think we'll stop there, but feel free to ask questions, and we can talk about your projects or other data. Yeah. Or you can, if you can ask a question for the whole class if you want to. Okay.